All right, can everybody hear me? I guess that's a yeah. All right, my name is MaxieZ. My real name is Thomas. That's what you can call me by either one. Let me scoot a little bit closer to my slides. I'm doing this talk today on web security, web hacking 101. The reason I do this is because, well, I wanted to talk about something, and it's what I do day in and day out. I am the lead tech at the largest adult web hosting company in the United States. So I have a lot of experience in this. So this is why I'm talking about that. So what this covers is web, of course, being port 80 or 443 traffic, as opposed to just general hacking where you're looking at scanning ports. This is specifically attacking a website, hacking obviously, and 101 because a lot of what I'll be covering here is really the intro into how the web server itself is secured, and then going a little deeper into how you can exploit that server to run your own commands upon it. In general, of course. I mean, hopefully we can all secure ourselves to some degree. Everybody happy? All right, and feel free to ask questions too. Another part of the 101 is that this is it's somewhat basic, but depending on your level, it may seem I don't know. But if you have any questions, just feel free to ask. So this is the breakdown. I'm going to cover authentication methods, basic authentication, SQL authentication, DBM. I think I'm feeding back. Referring authorization, which is basically, hey, Bob over there, he sent me to you, and now you should let me in. Basic web hacks, should I have checked that variable? And how to catch malicious code. All right. What I'm not talking about, because this is also relevant, is attacks on web servers themselves, because attacks on the web servers are very specific. Unless we're talking about Apache 2, it's pretty rare. And so in general, there we are. And I shouldn't turn my head without the microphone. All right. So I'm also not talking about turning off options. A lot of times when I see a document about how to secure a website, the first thing out of the box they say is, don't allow this, don't allow this, don't allow this, don't allow this. And at least in my environment, I have to allow everything because my customers expect everything to be allowed. So if I don't, then they get mad, and I can't do that. So basically, the point is how to secure your site, even if you have to have those options on, because in general, a lot of people have to have those options on. And also, I'm not going to talk about obvious things, firewalls, CH routing environments. I mean, these things are there. They're important. I'm not saying that they're not, but at the same time, it's not really the point of this talk. I need to stand back a little bit more, I think. No? Right here is good. All right. The first important thing to know about HTTP communication is it is stateless, as opposed to like FTP or even mail. When you connect to an HTTP server, you say, give me something. It gives you something back. That's about the end of the experience. There's nothing really else going on. This means that every time you authenticate, you have to authenticate again. That's the first important thing to know. Every time that you come back to that server, it doesn't know who you are unless there's a cookie or something like that. But those are other methods that have been implemented. This makes spoofing easy, obviously. Anytime you have to send communication and you expect any kind of communication back, it doesn't really matter what you get back. It's very easy to spoof, or, of course, that you expect the communication back. So spoofing HTTP traffic is very easy. Of course, you're not going to get the data back to you unless, of course, you've done more complicated things. But, it's easy to fake your traffic so that the logs look different. There we go. It makes more authentication a bit more difficult because it doesn't remember you. It's not like you logged in, you do your communication, and then you quit. No, it's like you have to log in, you get your information back, you come back later, you get your information back. It's every time you see something, it's something new. HTTP authorization. There's several methods for this. I'm going to cover these three real quick. DBM, SQL, and HTTP. As far as the browser is concerned, these things are all the same. You get a prompt, you get a 403, I believe, and it's a 401. And you are then asked to supply your username and password. In so doing, it's base 64 encoded, and then you send that back on the next request. So every time you go to a website and you get that pop-up box, you've already got a failed login attempt. You basically went to it and said, oh, you don't have a good username and password. It then sends you the 401, and then you enter in your username and password. You can see right here the authorization basic. This is what the line looks like when you're actually sending in a request. This is base 64 encoded. with the username and password with a colon in between. That's all that is to it. So if you know how to do base64, there's plenty of base64 encoders and decoders out there. In fact, there's one on my website. They will tell you, what the username and password was. So I actually thought about this on the way up here. I say passwords are sent in clear text. That's not actually true because they're base64 encoded. But passwords are not encrypted is the right way to say this. And just to give you an idea, I would say 95% of the websites use this type of authentication. There's nothing else, no other form of encryption going on your average adult or pay site. It's just simply username, password. I hope you got it. All right. This also leads to brute force attacks. Well, it doesn't lead to brute force attacks, but these are the problems that face the internet. Brute force attacks happen a lot on sites where people come in and there's no, because it's stateless, it doesn't know that you've already tried and failed so many times. It just allows you to keep coming back. That's default behavior. And password sharing. If you have some content, it's very common, if anybody knows anything about surfing porn, to get a password, sign up to a site, and then you go to a site and you share that password. Or you go to that site just to get a password, and then you can log in with that password. This isn't so much a problem for the surfer, because he's generally happy getting what he wants, but for the site owner, he gets rather upset because his bandwidth bill goes through the roof because all of a sudden he's got 5,000 people signing in as Mr. Man. All right. So, yeah, it's a big problem for the pay site owner, the guy who's footing the bill. For us personally, we make more money, so we're happy with it. Fixing these problems. SSL sites are great to prevent clear text transmission. Hold on, I've got a slide I'd rather go. Yeah. Let me cover this one real quick. But what about off digest? Off digest is I hate to say the word new because it's very old, but it's a different type of authentication in which when the 401 request actually sends some salt, salt being just some random keys that's saved, and the web browser gets it, MD5's the salt and the password that the guy puts in, and then that is then sent back up to the web server on the next request. This is really a preferable method, but the downside of it is if you're using a very old browser, it won't work because the browser doesn't support it. Secondly, if you have, let's see, what am I thinking? Lost my train of thought. Oh, yes. OK. If you are sniffing the traffic and you see this encrypted packet go up, which would look, much like the one you saw before, it's not SSL encrypted so much. It's just the password is encrypted. So you actually see the password go up. And if you saw that, there's nothing stopping you from just resending the authorization code encrypted just like they encrypted it, and you can get right in. And secondly, of course, the data is not encrypted. Without the data being encrypted, then how much work have you actually accomplished? Depending on what the site contains, you may want your data encrypted as well. Okay, so fixing the problems. SSL sites to prevent clear text transmissions. SSL, of course, everybody knows. Hopefully, SSL is a way to encrypt your data over a standard TCP string. The downside of SSL, really, for websites is that there's not a lot of IP addresses that a website master can have or a web host can get. Aaron is being very strict about how many IP addresses. There's a lot of people who say we're running out. Anyways, so for an SSL site to work, because the traffic has to come in per IP, we have to know the key to decrypt the traffic with. And so therefore, you can't share sites on an SSL server, or you can't share IPs on an SSL server. So as such, you won't see this really implemented to a large degree. Even though most browsers now do SSL by default, even though buying a key is inconsequential to the amount of lost data you'll have if your usernames and passwords get out, it's just simply not viable in the current infrastructure. Maybe with IPv6 it'll be something different. Some methods to prevent password protection brute force. They're in the wild today, are ProxyPass, Pennywise, iProtect. To prevent brute force. Sorry, I keep moving back. I recommend ProxyPass of these three. It's a Apache module. iProtect is also decent. I've never tried it. Well, no, that's not true. I've tried it, but I don't have a lot of experience with it. ProxyPass has really good support, so I'm happy with them. And I emphasize beware security problems with these because a lot of times these things run as root. They're embedded into Apache, or they're running as scripts right out of Apache. And I've seen instances where, especially with one of these, where they were starting up as root right out of Apache, and then the file that they were calling was the same CGI that the web server hit. And because they wanted to be able to hit it, they were recommending to all their customers to set this file to be 777. So basically, you have a file that 777 is root's calling, every time Apache's restarted. Not really a good situation. Also, of course, anytime you load a module into the code of Apache, you're compromising the security that is Apache unless you know that code. And in both of these cases, these modules are proprietary, so you're not going to get the source unless you're sneaky. All right, we already covered that. Referring. HTTP, funny thing is, actually misspelled the word refer, so I misspelled it here to pay homage to that. So referring basically is a type of authentication that's, believe it or not, used a lot, in which it's client-based, and the client says, hey, I am me, and Genflux over here accepts any kind of authentication from me. And so all I have to do to get into Genflux's good graces is to say, hey, Thomas sent me. Okay? And worse than that is, of course, Genflux has to accept himself. Remember, this is stateless. So every time you come back, you're passing a new refer, and the refer you eventually are passing is, of course, yourself, right? So every time that Genflux is hitting himself, or this traffic is coming back to himself, he is then accepting it. So one common thing to do is say, hey, Genflux, I'm you. You sent me. It's all good. And, of course, he says, works for me. So this type of authentication is actually in use quite a bit. Reason for that is because there's a lot of content in one place. The authentication becomes a problem. They want to share that content to other pay sites, and the way they do that is they simply say, I allow this guy in, but nobody else in. Okay, so that's how that works. Systems to fix this, of course, without just requesting authorization again, is to move the files periodically, to use symlinks that are removed and re-added, and, of course, using cookies, which is always a good way to do it. Generally, none of these things are used. Referring is still the #1 way to do this. Just simply trusting that the website user or that the surfer is being honest and coming from where he says he's coming from. And so, happy surfing. All right, so that's it for the authentication. I'd like to ask questions if there's any, because I went over that fast. And if anybody has any question about the way HTTP works or any way about the authorization methods that we've already covered work, please ask now. Yeah. Right. Right. Generally, the only thing I know that's blocking that in use is IE6, and that's a latest patch. So it's a browser-side patch, not a server-side patch. What generally happens there, the way these systems work, of course they're different, but in general what they're doing is they're analyzing the traffic as it happens. If they start seeing a lot of 200s from the same username from multiple IP ranges, usually multiple Class Bs, they don't care so much about Class Cs because of AOL proxy servers, et cetera. They will start to block that user as a password trader because he's logged in more than once. A lot of times, these softwares can be very stupid, too. I've seen people blocked as password traders because they were logging in, spoofing their IP addresses in a public area, and changing different usernames to try and guess the passwords. And of course, there was no password protection. But then the software said, oh, well, he's getting in on multiple IPs. He must be password trading. So it would block that IP address or those IP addresses. That's generally how that works as far as password trading goes. That format you're talking about, the HTTP :/username :password, then at the URL, is just a standard in creating URLs. And all it really means is here's my username password, and do something with FTP. But it's not really treated any differently as far as the server sees it. It's already interpreted differently. Any other questions? Yes. The question is basically if essentially if I keep getting different salts and I use the same password over and over, how is that going to work? And the answer is that it's always the same salt. The way that HT Digest works is that when you create the password, it generates salt right then. It creates the MD5 of the password that you supplied with the salt, and it just passes the salt, and then the MD5 hash is generated, and it compares that MD5 hash to the MD5 hash. Yes, that's true. If there was like a changing salt, yes, that would absolutely work, but no one is, it's not implemented yet. Well, I don't think this has anything to do, are you talking about on IIS? I'm not familiar with that, but maybe they do. Okay. I don't know. I'm honestly more of an Apache guy, so I don't. I've used IIS, but I don't know. Nope, doesn't. That's how it works in Apache. And my password, my screen's over there. Sorry about that. Should have killed that. All right. Any other questions? No. Okay. So part of this, I hope my internet access is okay. On to exploits. Web servers are often exploitable. Other services on web servers are exploitable. However, the most common security problem facing the web right now is PHP and CGI scripts. Okay, because as I said in the beginning of the talk, web servers, when they get a patch, generally they're going to be upgraded. People are going to keep up to date with them. Yes, it's going to happen. Yes, there's going to be Apache scalps again. But by and large, the most common problem that I see day in and day out is PHP and CGI programs that are written poorly. And of course, there's also going to be attacks on the other services, which is basically what I just said. So what went wrong here? I mean, why do we have all these issues with the web? By and large, the web has taken over the internet. It is, you can do your email, you can do IRC, you can do anything that you want to do in almost any way on the internet, you can do now on the web. Of course, with it being stateless, it certainly wasn't designed that way. The intent was to simply give you a web page and a way to get somewhere else. But now we have, intercommerce business happening over this simple protocol. Okay, CGI PHP problems. System calls are on unvalidated data, user supply data. This is the most common attack against web servers today, period, bar none. Basically, I'll demonstrate this in a little bit, but basically this is the web surfer supplying data to the script that is not checked, and then a system call is run. And that's what is happening around the world. And then, of course, the real cause of that is just that so much more is asked of HTTP, that now it has to do intercommerce, and it has to do your banking and your basically anything you could ever want to do on the web, on the internet can be done in the web, and it simply wasn't designed to do that. So we've embedded all these things into the web server to make it more powerful and more insecure. Overriding include paths. This is something you see a lot in PHP. Basically, what happens is that there is a website that is going to include some library files, and you are able to supply it with, instead of getting your libraries from this area, get your libraries from this website over here. This mainly happens in PHP, especially with register globals on, which basically means that you can pass any data right to the web browser. And you can imagine what that library must look like. It's something along the lines of, create a JPEG, because that's what the name of the function they're going to call would be. And then inside of create JPEG, instead of creating a JPEG, now it's, start a shell on port 4443, example like that. Of course, other problems exist, and I'm not saying they don't. Of course, there's holes in all kinds of software. I'm just simply saying that these are the ones day in and day out I have to deal with as a website administrator. Okay, so ways to fix these things without fixing your scripts from the get-go. See, the point being that I can't control my customer's data. I can tell him when I find it that it's bad, but I have 1,500 servers running. I can't very well validate every single file that's uploaded across the board. It's a bad place to be. So one module that's come down the pipe is called mod security. Mod security is an Apache module to blacklist variables. For instance, if I typed in include equals /temp, it's going to say, that's not allowed. I'm not going to do that, just by default. Now, of course, does this break sites? Absolutely, this breaks sites. But at the same time, it also will make sure that your sites are a lot more secure. Let's see. Yes, a downside of mod security, of course, is it's often used to ignore vulnerable scripts. I'll just upload this vulnerable script, and I'll just trust it now that it's vulnerable. It's very good at finding hacking attempts, and it's good at frustrating hackers. But it's a Band-Aid on a severed limb because it's a blacklist more than anything. Blacklist, you ask any security expert, he's going to tell you blacklists are bad. Because what ends up happening is you say, you can't do this, you can't do this, you can't do this, and then I find a way to do this, which is, in the end, the same thing. It's always much better to whitelist things to say you can allow this, you can allow this. But you find yourself on the web that, just like I said, my customers can upload anything. Therefore, I have to accept nearly anything as a possibility. So it is a Band-Aid on a severed limb. It's very good at finding hacking attempts because your first guess when you're trying to break into a system would be to do /temp or run wget, and it's going to block that. So you're going to see the blacklisted things, but then they're going to get around it eventually. And so the idea here is to just to have a log of who's hitting it, how they got in, what they were attacking. Mod log forensics. This is actually part of Apache since I think 1328 in the one line. It does have a bold name, but this module doesn't do anything more than logging requests before and after a request is made. I know that sounds kind of silly, but the way Apache works by default is that the log is the last thing that's written because it has all the data at that point. It knows that the file was completed, it knows how many bytes were transmitted, and it finally is able to log that, hey, I'm done and life is good. This can be a problem, especially if somebody's taking your Apache process and making it run their own bind shell. That process isn't going to finish. It's not going to come back to the regular process. It's not going to be logged, so you're not going to be able to find that as well. So mod log forensics is very useful for debugging attacks against a web server because you can see the traffic before and after. And then mod DOS evasive. It's not much of a system security helper, but it does prevent brute force attacks. Basically, if you see the same attack hit over and over and over and over and over and over, it will IP tables block that site away. So, well, it depends on how you configure it. I believe by default it's permanently. You'd have to write some other script to free it up. Okay, run Apache as its own user. And I say this more to let you know what's going on the internet than anything. Most installations do this by default. By default, you'll see nobody. Many host companies do not do this for convenience. That's the scary part. What they do is it's so much of a pain in the butt when your customer calls up and he's like, I can't edit my files that the web browser wrote, and I can't do these things. So what they do is they say, okay, well, we'll just run Apache as your user, and then whatever permissions it has, or you have, it has, and then life is good, right? Of course, this gives an open door to any files, any directory on the entire system that the user owns, you now own. Any script he owns, you now own. So that's a good reason not to do that. Audit this user that you run Apache as. This user shouldn't be doing hardly anything. He's running a website, he should maybe be calling 1 or 2 or 3 scripts. Other than that, he's running HTTPD. If you see anything going on besides that, there's a problem. All right? Make a white list of what's allowed for this user to run, and only log everything that's not in that white list. Have it, wake you up and get you out of bed because your site's about to be compromised. I wanted to cover SQL injection, even though it's not really a system attack, because it's such a widespread thing. Most sites now have an SQL backend, the big sites anyways. And what is very common to see nowadays is someone will get on there to a site, exploit it, get into the SQL portion of the code, and then change the site that way without actually touching any file. The general way this works is a good example is select user from auth, where user equals user and pass equals pass. This is some code, for instance, if you wanted to log into the site and you want to say the username is this and password. It's a logical query. You'd look at that and you go, well, that makes sense. But what if the user equals Bob and pass is equal to Bob in single quote or 1 dash dash, a dash dash starting a comment. Your query now looks like select user from auth where user equals Bob and pass equals Bob or 1. So 1 is true, you're in. That's a good example of how you can get into a site that works on many sites. And you could also, of course, do any other kind of query just by putting a semicolon at the end of that. This also has to do with validating your data. And that's the end of my presentation as far as that goes. But I would like to demonstrate, if I can get online here, how these scripts work and how you can exploit a simple script, CGI that you would think was perfectly legitimate. So let me put this in here and irritate you all. I don't know how this goes in here. Sorry about that. All right. So I don't think that was me. Can you hear me? All right. So let me see if I'm online. I don't appear to be online, so let me show you quick what my script would look like. Have to be root to do that. While that's going on, let me show you a little bit of the code that I'll be executing if I can get online. Is that my fault or? I don't know what that is. Okay. Okay. This is an example bit of code that I wrote. Can everybody see that? All right. Yeah, that looks pretty good. All right. I wrote this code being stupid. Basically, what I had done is I was working on a bunch of encryption algorithms at the time, and what I had done was I had learned that ROT13 had a really cool system call that you could use to ROT13. It looks very much like this. I'm sorry about that. In this area right here where it's user bin tr. Basically what this does is it converts the letters to another letter. And I had already written several algorithms that had been using the actual binary or the ASCII values and manipulating them and whatnot. But at this point I was lazy and I said, well, I got this great system call. Why can't I just use this? And so what I did, these backticks here mean system call. And whatever you typed in, I would just echo it using the system command echo, and then pipe it to tr, just like that. An example of this would be, let me just demonstrate this real quick. So echoing test, well, let me cut and paste it actually. So echoing testing to this, spelled correctly, will then give you a ROT13 little bit of data, which I have no idea why that's 2 lines. I suppose it's an inline. Yeah. I imagine this is grf gvat. And so I had taken that code and I had implemented it into my web script to ROT13 my code for me. This was like 2 years ago. One day I noticed that I had a bunch of odd paths. All right, they're going to turn me off for just a few minutes. Oh, just down. Okay, I'll just talk about it. They're trying to fix the popping noise. Can everybody still hear me?